Истинный висяк раскрыт. ОСБ, айболиты.
Перед лицом.
Ошибочное классическое распределение вероятностей.
Сзади 3 сложено.
Макс. Садхал.
Простая арифметика.
Запрос.
4-й энергоблок.
Для многих президенты метят как. Видел, как табор уходит.
Зодче, доктор Айболит. Зодче, оса, доктор Айболит.
В небо.
Ответ.
А за ним души тех, кто не стал президентом.
БКО ВКС, Белый лебедь. Дес Ориджинал. Росинка эффект. Больница, эпическая больница. Линейный усилитель. Алмаз Антей. Нереальный
Вот
девайс.
ключа.
Астрология.
Первым, что вынесут ноги.
Алмаз Антей. Нереальный девайс.
Страшнее всего забыть близких, пароли, логин.
Алекс.
И как ты
Софи Стар.
не старайся, масса.
Цех ускорителей.
Тут, бля, в позу доги.
Леот Кластер.
Цех-Тиватрон.
Дознаватели. Садисты-дознаватели. Не
Цех
стесняйтесь,
Оренбург.
все по сети. Контрольные каналы. NCI. NCI
Оренбург
Беларусь.
400.
Было бы
Астрология.
Цех Нобель.
пару лямов, блять. У меня было пару лямов. Я бы
Цех
поменял
бездна.
их, не
КДБ.
глядя. Хотя не поменял бы.
Хал. Омикрон.ком. Все по сети. Алмаз Антей, Росинка Рось. Фантастический коммутатор.
Уходит в небо. Я грабил даже
Равента.
там, где
Вот
не был.
ключа.
В голове бы мои мысли поумнее, ребята. Но я такой тупой, что гожусь
Фантастический Су-58.
депутаты.
ОСБ Шерлок Холмс.
Стоп, снято с предохранителя.
Обнаружен цезий.
По 105-й
Убийственный висяк раскрыт.
мой обвинительный. Под стол прятал ствол на глушителя и вообще
Босс след.
чисто зрительно я подозрительный.
Петровка 37. Оса Чупакабра. Космопоиск Чупакабра.
Силы МВД это злые силы. Хвосты, рога, копыта, вилы. И когда у
Фантастический Су-58.
дома полисмен.
Айкора. Ай-3. Ай-7. Ай-5. Все по сети.
Скот
12 управление. Фантастический девайс.
мрет, молоко киснет. А
Сюрреалистичная крыша оса. Руны. Рунический фрактал.
мы сразу после отсидки
ОСБ Шерлок Холмс.
оставим на керамической плитке. Опер поднимет бровь от удивления, что мы успели скрыться в неизвестном направлении.
МТС
Тут те,
цех.
кто даже на
ОСБ СПРН.
Титанике скажут не
Ответ.
Леот Кластер.
Задаем вопрос.
сы. Те, кто в русских народных прибавят басы. И мы не бережем свое время.
Ромашка.
Цех новины ЧС.
Информационные листки. ФБР.
Когда ломаем часы,
ВКО.
это
ОСБ доктор Ватсон.
бандитские ребятки вуз.
Цех
Каспийский
Рефлекс.
Леот Кластер.
Задаем вопрос.
ребятки груз.
Дестанигов. Бездна.
И наш взгляд на наш взгляд верен. Старый ствол, ногу в пол, 63-й мерен.
Оса Чупакабра. Космопоиск Чупакабра. Информационные документы. Листки. Кубит. Убийственный висяк раскрыт.
Совещание с вице-премьером.
УСБ доктор Ватсон. Сам Digital. ОСА. Парадокс сложения вероятности, искривление вероятности.
Запрос.
Диагональная кривая. Искажение числа π. Искривление числа π. Снег,
Цех
лава.
Задаем вопрос.
Молот Шамиль.
Генерировать работу.
Алмаз Антей. Нереальный. ВКО РВСН. КДБ.
Вот ключа.
NCI Беларусь. Белолебедь. Фантастическая технология. 60-е года. УСБ доктор Ватсон. Холливуд кластер.
Запрос.
Фурье образ. 4-й энергоблок. Экспертиза.
Ответ. МТС цех.
Ведьмак.
Цех ЧС.
ОСБ. Фантастическая машина. Застава.
Цех новины
Шар
ЧС.
М55 комп В2. Поле чудес номер 2.
Цех Оренбург. Цех Теватрон.
Спарк.
Цех ускорители.
Убийственный висяк раскрыт.
Совещание с вице-премьером.
Ошибочная классическая КГБ. Фантастический эпический чудо-девайс. Обнаружен цезий.
Запрос.
Не верю, блять, людям и рыбам. Если
Косгальтен Крак. Садхал.
люди не близки, а рыбы не искренне. Видать, в ментовках закончились ластики.
КГБ. Фантастический эпический чудо-девайс.
Чтоб наши делишки
Алмаз Антей Росинка Рось.
Генерировать
Фантастический
работу.
коммутатор. Прямоугольное нормальное распределение вероятностей.
почистить, блядь. Нас видно в
УСБ доктор Ватсон.
бокс под землю, раз нас не видно.
Убийственный висяк раскрыт.
Совещание с вице-премьером.
Или мы каждый
Виталити.
Запрос.
Ленин Усилитель. Газета «Мужской клуб».
в своей перхоти чисто по миру.
Настоящая хиромантия.
Чисто по миру, переобувшись.
София Стар.
Ellegren, jag är ständig sekreterare här på Kungliga Vetenskapsakademin. Till höger om mig här sitter professor Eva Olsson som är ledamot
Журнал
av
издания криминалистики.
Nobelkommittén i fysik.
ОСБ СПРН.
Och till vänster
На мой бомб, как на Боинг, много пассажиров.
också ledamot av Nobelkommittén i fysik och sakkunnig inom ämnet.
Тут потеряет твое тело заживо
My
до
name is
жива.
Hans Ellegren,
Тогда скажи нам, кто
Secretary
тут
General
наживо,
of the Royal
если
Swedish
пять перед
Academy of
лицом и
Sciences.
сзади.
And to my
Белолебедь.
right is Professor
40.
Eva Olsson, member of the Nobel Committee in Physics.
Простая
Запрос.
Professor Lars
Зодчий
Hans
доктор
Hansson,
Айболит.
also member of the Nobel
Ответ.
Committee in
ОСА
Physics
доктор Айболит.
and expert
видел для многих
in physics.
президентов.
Цех Нобель.
Видел, как табору
Цех Белолебедь.
Pris
Антей Росинка
handlar om
Рось.
kvantmekanikens kraft.
ходит в небо, а за ним
This
души
year's
тех, кто не стал
prize is about
президентом.
the power of
Какого
quantum
рваса?
mechanics.
И первым, что вынесут ноги, страшнее всего забыть.
Kungliga Vetenskapsakademin har idag på morgonen beslutat att utdela 2022 års Nobelpris i fysik i lika delar till Alain Aspect, Université Paris-Saclay
Искажение числа
och École Polytechnique Palaiseau, Frankrike.
Вот ключа.
John F. Clauser,
Убийственный висяк
J.F. Clauser and Associates, Walnut Creek, Kalifornien, USA.
Тебя нагнут,
Och
бля, в позу.
till Anton Seilinger,
Pilotklassen.
Universitet Wien,
Информационный
Österrike.
ФБР.
Det tilldelas priset för experiment med sammanflätande fotoner som påvisat brott mot Bell-olikheter och banat väg för kvantinformationsvetenskap.
Химия.
The Royal Swedish Academy of Sciences has this morning decided to award the 2022 Nobel Prize in Physics in equal shares
Запрос.
Alain Aspect, Université Paris-Saclay, and École Polytechnique Palaiseau, France.
Ответ.
John F. Clauser, J. F. Clauser and Associates,
Цех Нобель.
Walnut Creek, California, USA.
Цех Теватрон.
And to Anton Zeilinger, University of Vienna,
Парадокс сложения
Austria.
вероятностей, искривление вероятностей.
They received the
Диагональная
prize
кривая
for
искажения
experiments
широты,
with entangled
искривление
photons,
широты.
establishing the violation of Bell
Цех
inequality
ЧС.
and pioneering quantum
Первый раз
information
подняли
science.
шухер.
Professor Olsson will now give us a short summary, please.
Информационные
So,
листки,
quantum
ФБР.
information science is a vibrant
Запрос.
and rapidly developing field.
Лучше меньше усилитель.
It has
Ответ.
great and potential implications in areas such as
Цех ускорителей.
transfer, quantum computing,
Вот
and
ключа.
sensing technology. Its origin can be traced to that of quantum mechanics. Its predictions have opened doors to another world. And it has also shaken the very foundations of how we interpret measurements.
Оса, чупакабра, космопол.
Вот ключа.
Today is considered logical,
Serenity.
measurable, and
Sea
quantifiable.
Secret Service.
Was initially debated by Niels Bohr and Albert Einstein in philosophical terms. John Bell transformed the philosophical debate into science and provided testable predictions that launched experimental work.
Информационные листки, ФБР.
This year's Nobel Prize in Physics honors the groundbreaking work in science of the central figures Alain Aspect,
Спарк.
John Clauser, and Anton Zeilinger, who took up the challenges of Bell and tackled them in the laboratories.
Борис Самогон, Сад Текила.
Professor Tors Hans
Supercity
Hansson
SAS. Full Control.
will present the details of the work.
Это бандитские ребятки вуз.
Серф Secret Service SMA 360.
For a more detailed presentation.
Генерировать работу.
Экипаж.
Introduction.
Ребятки груз.
Sea Secret Service.
И наш взгляд на наш
Сад Хал.
Einstein,
взгляд
in
верен. Старый
a letter
снова
to
много
college,
фол, 60
famously
ВВР
wrote,
1200.
I'm convinced that he,
мерен.
and he meant God, does not play God.
Алекс.
And what did he mean? Quantum mechanics,
Цех
the
ЧС.
theory of atoms and light, had been immensely successful, but it was also very real. For instance, take the simplest atom, hydrogen. Just one electron moving around the proton. Quantum mechanics couldn't even tell you where the electron was, just the probability to find it
Парадокс
somewhere.
равное 2.
Вот ключа.
Thought that a good theory should give you precise predictions, just as Newton's theory tells you exactly where the moon is in its
Ответ.
orbit around the Earth at every moment.
Сад Хал.
Not everybody agreed. Here are two
Sea
of
Secret
the
Service.
founding fathers of quantum mechanics, Niels Bohr and Edwin Schrödinger. They thought that quantum mechanics was okay as it was. Didn't need anything more. You just have to accept the peculiarities. And this position was put very clearly in this paper written in 1935 by Edwin Schrödinger. It was an answer
КГБ СССР.
to a paper
ППК.
written earlier that year. But
Цех рефлекс.
Boris Podolsky
Вот ключа.
and Rozen,
Контрольная
and they had come up with the thought experiments, which they thought proved, demonstrated that quantum mechanics couldn't be the
Идеальный
full
девайс.
story. And now I will explain to you a modern version of that experiment.
Обнаружена технология время.
So, here you see a source. This source emits pairs of particles, entangled pairs, bell pairs. We'll come back to that concept.
Алмаз
And
Антей.
they reach
Десятое
Alice
управление
and Bob,
железный капут.
who makes measurement. They measure the property of these particles that is called spin. And in quantum mechanics, this spin can only take two values, plus or minus. So what happens when you do it many times? Alice will see a sequence of pluses and minuses, plus, minus, plus, plus, minus, minus, plus, etc. Looks completely random. And the same is true for Bob. The strange thing is that when they compare the measurements, every time Alice sees a plus, Bob will see a minus, and vice versa, and that's very strange, because they are far away from each other and these particles look
Ошибочное
exactly the
классическое
same.
распределение вероятностей.
So, well, perhaps, let's look at it. Here we have the quantum cards. They look all the same, huh? We shuffle them or entangle them, and then here they go. And they can answer questions on signs. What sign do you have? Plus? What
Старая
sign do you have?
пламенная история.
Minus.
Билибина, нереальный девайс.
Okay.
Full control.
Let's take another set of quantum cards. Here they go.
Убийственный
What sign?
рисак раскрыт.
Plus? What sign? Minus. Strange. They look the same. How could they know what sign they have? Well, you see, here
Охлаждаемый
Цех ускорителей.
прямоугольный нормально распределен.
Вот ключа.
is the following thing. That was a minus, and that was a plus. So each entangled pair had one plus and one minus. Well, the minus went there or there, but it was always one plus and one minus. So, could it be that quantum mechanics was the same?
ОСБ.
Could it be that there were hidden informations like on the card? Could it be that nature was a
Как-то
trick?
так.
Okay, just like that.
Парадокс n равное 2.
Perhaps
FT.
quantum mechanics
Клик.
is not complete.
Собирается
Perhaps there is
образ
something
обратно.
hidden. Einstein would have liked that. And it's a very natural way to
переворот.
think that it would be like that.
Запрос.
Years went on, decades went on. No one found such a theory that could explain the experiment with such hidden variables. So this became something more of a philosophical question.
Запрос.
Physicists didn't care very much until in
Райза и подруга Банщикова.
1964, John Bell made an amazing theoretical
Убийственный рисак
discovery
раскрыт.
by
Зодчий
looking
Кремль.
at a
Сюрреалистичная
variation
крыша оса.
of this experiment that I just
Ровная.
told you about.
Хронический
He
фрактал.
could show that in that case the predictions of quantum mechanics couldn't
Astrolog.
be reproduced by any kind of theory based on hidden variables,
Оса
however
ОСБ.
complicated.
Фантастический автомат
And when you think of it,
УВБ-76.
that's really strange, because that means that
Лёва
when you
кластер.
measure
Запрос.
particles, it's not so that you just
Ответ.
remove the property that is already there and measure.
Контрольные
No,
каналы
the
ваши,
quantum
RAF ваш.
information about the state is in the full, entangled state of both particles. Indeed,
Цех бездна.
and so thought
МТС цех. Цех ускорителей.
who said.
Запрещенная химия.
Цех Теватрон.
Let's
Цех новиночек.
Bell's
ВКО.
Let's perform it in
Щит.
lab.
Лёва класс.
Задаем вопрос.
Right in that video. Now, that was easy to
Генерировать
say,
работу.
because with the existing lab
Парадокс n
equipment
равное 2.
you
FT.
couldn't perform that
Клик.
experiment.
Не собирается
But with
образ
collaborators,
обратно.
he came up with a variation of the experiment that
Убийственный
could be
рисак
performed,
раскрыт.
and he and the late Stuart Friedman went to the lab. They
След.
did it, and they found
ОСБ. Сапфир.
that quantum
Фантастический.
mechanics works
Эфир.
also in this case. Now, there were loopholes.
Запрос.
РБМК
And
1000.
one particular loophole that John Bell
Core,
had been
I3,
very concerned
I7.
about was
Цех
that
NCI.
that means that
positive.
Alice shouldn't be able to send signals to Bob so they could sort of agree
Astrolog.
on the result of the measurements. And that was
Оса ОСБ.
hard to exclude
Фантастический автомат
experimentally.
УВБ-76.
Ответ.
But in 1976, Alain Espert wrote a paper where he proposed
Vitality.
such an experiment. And a couple of years later, went to the lab,
Виталити.
performed the experiment, and guess began
Vitality.
quantum mechanics roots. So,
ВКРВСМ.
why is this a big deal?
Вот
We didn't know
ключа.
how quantum mechanics works. Well, to explain to you why it's such a big deal, let's go back again to 1935. Here is another paper by Schrödinger, which he says, I would not call entanglement one, but rather the big trait of quantum mechanics.
Алекс.
So now, much later, in
Какая
Red,
дихлофос?
we understand that in addition to the
Оса ОСБ.
profound
Фантастический
philosophical
автомат
and
УВБ.
foundational implications of the Bell,
Снегов.
of the studies of
Бездна.
Bell states, the experiments performed by Clauser and Asper opened the
ВКРВСМ.
eyes of the physics community to the depth at Schrödinger's state
Химия.
and provided tools for creating and manipulating and measuring states of particles that were entangled, although they were far away. And physicists now started to understand that entanglement and Bell pairs is a quantum resource that you can use to achieve amazing new things. And it's no time here to even start to tell you that story. I will just give you one example, which is picked because it illustrates one of the many groundbreaking contributions by the third of this year's laureates, Anton Zeilinger. So to understand this, you have to know that the goal of quantum mechanics today is to build a
Запрос.
quantum network. What is that? The quantum network is a series of nodes,
Сапфир. Фантастический.
and
чудо-девайс.
these nodes should be able to communicate via quantum entanglement. In these nodes, you can have quantum devices like encryption devices. How do you build such a network? It's difficult because entanglement is brittle. If you send it to an optical fiber, it's very easily
Цех NCI.
destroyed. So you
Цех
need
Теватрон.
some new
Цех
trick.
ускорителей.
And just an amplifier won't work
Вот
because
ключа.
amplifiers
Запрос.
Зодчий, Кремль. Без.
So here
Борис
is the
Самогон,
trick,
Борис Самогон,
the method that
Саттекила.
Anton Zeilinger
Все по
came up
сети
with.
СЭС. Full
It's
control.
called entanglement swapping. You have two of these Bell pairs like this. One of the particles here, one, and the other four goes far away from each other. The two other comes together. Here, you make a measurement, so you entangle particle 2 and 3. And then magically, 1 and 4 becomes entangled, although they had never been close to each other. It's wonderful. So now you can think of doing it in a chain. You do one, you do another, you do a third, etc., and you can build up a network. Another method to get long-range entanglement is not to use optical fibers, but to send just light through the air. And I'll just give you one spectacular example of this. And that was in 2018.
Запрос.
There was an
Ответ.
intercontinental quantum link set up using the Chinese Mikius quantum satellite between the group of Jianwei Pan, the Academy of Science in China, and with Anton Zeilinger's group in Austria, over 7,600 kilometers. Pretty amazing. And now we are at the forefront of current research, and I will
Цех ускорителей.
end with a few comments.
Сапфир. Фантастический
So
чудо-девайс.
today we honor three physicists whose pioneering experiments showed us that the strange world of entanglement and Bell pairs is not just the
Министерство
micro
обороны.
world
Оса.
of
Духовники.
atoms, and certainly not the virtual world of science fiction or mysticism, but it's the real world that we all live in. And researchers now all over the world, they use entanglement and Bell pairs, both in curiosity-driven fundamental research and in utility-driven applications such as quantum cryptography or quantum computing. Thank you for listening.
Thank you, Professor Hansson.
убит.
Now we shall see if we may have one of the
Алмаз
laureates
Антея
with us.
Фантастический коммутатор.
Professor Anton Steilinger, are you there?
Парадокс сложения вероятности, искривление вероятностей. Диагональная кривая.
Good morning, Professor Steilinger, and please accept our warmest congratulations to receiving the Nobel Prize in Physics.
КГБ. Фантастический, эпический чудо
Thank you very
девайс.
much. It was very kind to receive your phone
Alex.
call just about an hour ago. And I'm still kind of shocked, but it's a very positive shock. Thank you very much.
Охлаждаемый мозг,
So
умеющий
were you surprised to get the call?
Yes, I was actually very surprised to get the call. Thank you.
Yeah.
убийственный висяк раскрыт.
I'm sitting here in the session hall of the Royal
Ответ.
Swedish Academy of Sciences, and we are at the press conference live here. There are many interested journalists from the international press as well as from Sweden.
ФСБ доктор Ватсон.
Would you be ready to take some questions from them?
With pleasure, yes, but I don't understand Swedish, but
Настоящая хиромантия.
I'm sure they will ask in English at least. Questions?
САР М-55 комп
СВТ?
В2. Поле чудес номер 2.
Добрый день. Добрый. Сегодня будет оригинальная история фазовой стимы, как это должно быть.
Запрос.
На ускорителе такое невозможно. Задействован снег и гранит.
Финиталя комедия.
Фазовое дело нюансы воды и гранита.
Да, ну точно.
Ну, сейчас вы увидите, как это должно быть. История сейчас начнет восстанавливаться.
Спасибо.
Я
посмотрю.
Сейчас увидите.
yes,
Спасибо.
excellent quantum teleportation uses
Я тебя не умею любить, я тебя умею желать, бесконечно с тобой быть, безупречно тебе лгать, бесконечно с тобой быть, не встречаясь взглядом твоим. Я тебя не умею ждать, я верна измерениям иным. Ты любишь осколки, тебе надо немного. Моя душа сколько могла бы тебе отдать, но если бы снова мне было бы больно, я знаю, насколько мне страшно теперь мечтать. Ты любишь осколки, что в них толку? Держи мою руку и рассвет встречай. Держи мою руку. Здравствуй, утро, записка и пудра, было в кайф, прощай. Я тебя не умею любить, так же проще может быть. Я танцую, где полный мрак, ты уже не умеешь так. Тишиной заслонить эфир, удивить красотой мир. Я могу быть хорошей в снах и убить себя просто так. Ты любишь осколки, тебе надо немного. Моя душа сколько могла бы тебе отдать, но если бы снова мне было бы больно, я знаю, насколько мне страшно теперь мечтать. Ты любишь осколки, что в них толку? Держи мою руку и рассвет встречай. Держи мою руку. Здравствуй, утро. Записка и пудра. Ты любишь осколки, тебе надо немного. Моя душа сколько могла бы тебе отдать, но если бы снова мне было бы больно.
Запрос. Ответ.
Ты любишь осколки, тебе надо немного. Моя душа сколько.
Финиталя комедия. ВВР 440. Nokia 440. Финиталя комедия, все по сети.
avenue for new research.
ОСБ, Сапфир, фантастический чудо-девайс. Борис Самогон, Борис Самогон.
Запрос.
Все по сети СС.
David
Full
Keaton
control.
from the Associated Press. Congratulations, Professor. First of all, I'd like to ask, what, in your opinion, signifies this prize for the field in general of quantum mechanics? What does it mean for this field of research? And second of all, in 2022 today, what excites you the most in this field? What areas do you think are going to be yielding most new discoveries, both theoretical but also maybe practical? Thank you.
Second CI.
Well, I mean, this prize is an encouragement to young people, and I would mention here
Цехтиватрон.
that the prize would not be possible without more than 100 young people who worked with me over the years and made all this possible, because I alone
Первый раз
could not
подняли
have achieved
шухер.
that is quite clear. So I look at it as an encouragement, particularly for young people. My advice would be do
Вот
what you
ключа.
find interesting and don't care too much about possible applications. On the other hand, I understand this recognition is very important to development of possible applications, and this is going to be quite interesting. I mean, I'm curious what we will see in the next 10 or 20 years. That is, in my eyes, absolutely quite open. On the foundation, the fundamental thing, the issues about reality and the whole of space-time in a very fundamental way is still not answered, and I expect some interesting experiments there in the coming years.
Okay, we have more question here, please.
Congratulations, Professor Denninger. So this is Jun speaking from Geneva Observatory. So my question is, what happens if we send an entangled particle into a black hole? Do we still get information from it? Thanks.
Digital, ASA.
So this is a very basic question about the nature of black holes and what happens there. I should say I'm not a specialist for that. I mean, you know, the last year there were earlier prices for black holes. Also, there is a black hole in the center of the universe. And probably Professor James.
Задаем вопрос.
I have a naive idea. My naive idea is that I think information cannot be lost forever. But that is just my personal opinion.
Yes, please.
Anneli Megner Arn, Swedish TV4. Congratulations on the prize. I would like to fill in Thomas von Heine's question from SVT. And when you were talking about teleportation, when I think of teleportation, I think teleportation of mass, like a person is
МТС цех.
there in different galaxies. But you said teleportation of information only. Is that correct? So there is no mass involved here?
Well, actually,
Вот ключа.
This is a very good
Фантастический чудо-девайс.
I like that. The point is actually that it does not matter which mass something is composed of. For example, if I exchange all the carbon atoms in my body with the carbon atoms in somebody else's body, I feel the person doesn't matter. Important is the information. How is the object constituted? How is all these constituents arranged together? And that is what defines individuality and so on. Not the matter of which we...
Обнаружена технология время.
So you mean that in the very, very future, like maybe 10,000 years from now, you might be able not to actually jump to another galaxy, but have yourself building up again from different material at another place, like the same that we are sending TV now, for instance.
РБМК 1000.
That you get.
Well, at first, I might
Убийственный
say
висяк
that
раскрыт.
I'm not,
Парадоксы
I don't
главные
think
два.
that I will experience anything in 10,000 years. So that's a different question. The teleportation of people is today the same kind of science fiction as it always was. So this is just science fiction. It is not, in my eyes, it is not a question of science.
Okay, obviously a very exciting topic with an exciting last question here. I think this was the last question from the press to you, Professor Seilinger. Thank you, and once again, congratulations for the receiving the Nobel Prize. We look forward to meet you here in Stockholm.
Добрый день, дорогие друзья. Приятно в таких условиях открывать нашу всероссийскую выставку.
Серф Secret Service SMA 360. Леот кластер. Битбайт каратель.
No questions. One here, please.
12-е управление. Фантастический девайс.
Yes. Hello, my name is Linda Norstedt. I'm from the technology newspaper Ny Teknik. I wonder if you could tell us a little bit.
Вы больше не в Канзасе.
Запрос.
Вы на Пандоре. Вы больше не в Канзасе. Вы на Вы больше не в Канзасе. Вы на Пандоре, дамы и господа. Помните это каждую секунду, каждый день. И если ад существует, вы легко сможете отдохнуть там после службы на...
Астрология.
But when looking at the complete field that started, that was initiated by these groundbreaking experiments, the committee found that it would be wrong to just pick some of the very spectacular elements that has appeared lately, like teleportation, you know. It's something that really makes headlines. But we wanted to go back and also honor the people who laid the ground for what was to become. So that, in short, was the model.
With that, we will close the press conference. Thank you all for attending, and we hope to see you again here tomorrow at the same time. And we will present the Nobel Prize in Chemistry for 2022. So, thank you.
Убийственный висяк. Алекс.
Запрос. Эльза и подруга Банщикова.
Астрология.
Это злые силы. Хвосты, рога, копыта, вилы.
САР М55 комп В2. Поле чудес номер 2.
И когда у дома полисмен, Скотт мрет
Кубит. Сам Диджитал. ОСА.
молоко киснет. А мы сразу после отсидки оставим на
Информационные документы, листки.
керамической плитке.
УСБ доктор Ватсон.
Опер поднимет бровь от удивления, что мы успели скрыться в
Термоядерно-убийственная хиромантия.
неизвестном направлении.
Макс.
Те, кто даже на Титанике.
Сюрреалистичная крыша ОСА. Руны. Рунический фрактал. Охлаждаемость ОПЭЧ.
Скажут не ссы. Те,
Сам Диджитал. ОСА.
кто в русских народных прибавят басы.
Госпереворот.
И мы не бережем свое
ОСБ Айболиты.
время, когда ломаем часы. Это бандитские ребятки вуз, каспийские ребятки груз. И наш взгляд на наш взгляд верен. Старый ствол, ногу в...
Убийственный висяк раскрыт. Парадокс n равное 2 FFT. Охлаждаемый усилитель. ОСБ. Фантастическая машина. Застава. Фантастическая машина. Первый раз подняли шухер.
Третий мерен.
Ведьмак. Парадокс n равное 2 FFT. Клик. Не собирается образ обратно. КГБ. Фантастический эпический чудо-девайс. Газета «Мужской клуб». Обнаружена технология время. Убийственный висяк раскрыт. Алмаз Антей. Нереальный девайс. Алмаз Антей. Нереальный девайс. Охлаждаемый мод, шумящий усилитель.
Запрос. Генерировать работу.
Поиск Чупакабра. КДБ. Красноярск 40. Оригинальный двиг Кубит. Суперкомпьютер, квантовые компьютеры. ОСБ Шерлок Холмс. Министерство обороны. ОСА. Духовники. Борис
Professor Tors Hans Hansson, member of the Nobel Committee, please explain what is this year's prize about?
This year's prize is about quantum mechanics, and I'm sure you've heard of quantum mechanics, and it usually is portrayed as something which is sort of very weird, very mystical. And it's true, there are weird and almost mystical aspects of it. But this year's prize is for work that has made clear what quantum mechanics really means. And the really sort of funny thing with quantum mechanics is that normally you think when you have, if you have sort of, say, billiard balls or something, you have one ball here, you have one ball there, you have one ball there. And you can look at this ball and you can say, is it red or yellow or white? And you can look at it and it's red, yellow and white. It has nothing to do with the other balls. And then you can look at one of the others and see, what color does that have? In quantum mechanics, it works differently. You can have quantum mechanical states which are called entangled. And then, when they are entangled, then you cannot just look at this one and say it's yellow without somehow affecting what is happening to the other one. This is a very, very strange property of quantum mechanics. And what this year's prize laureates have done is to sort of make us understand a bit better about what is going on, understand more about the nature, this peculiar feature of quantum mechanics.
And how does it affect our daily lives or our lives?
Well, that's a question you always get for the Nobel Prizes.
Why not?
Yes, why not? So, you know, if we discover something about cosmos, what does it have to do with everyday life? Well, perhaps nothing, but it's still wonderful that we can understand these things. And one aspect of this prize is exactly that. We understand something about nature that we didn't understand or didn't understand properly before. And that is something which is in the committee's, opinion, is prize-worthy in itself. Then come to applications, because there are certain prizes. One year there was a prize for blue diodes, directly of importance for the bulbs you put in your socket. And there are aspects of this year's prize that have some practical implications. For instance, you can have something that is called quantum cryptography. That is a way to use entanglement, this funny property I told you about, to send secret messages in a way that cannot be intercepted, cannot be eavesdropped to. So that is one application that actually exists today. Those devices you can buy. If they will become very important in the future, will it be only something for banks and militaries? I don't know. But it is a practical application. Quantum computers might in the future. That's in the doing. Still, we don't have a quantum computer, but who knows? Huh?
So why is this recognized now? Why now? All of the experiments, the first experiments came very early, Still, the implications of the development that was set in motion hasn't been clear before much later. I would say within the last 10, 15, 20 years. And then, of course, it's always, why this prize this year? That we never answer, because there are, of course, many alternatives. And this year, this alternative came on top. You were a little late in, and there are 3 laureates this year. Was there a problem finding them, or? Not so much, actually. Could you tell us something personal about any of them? Is there something specifically interesting?
Oh, you mean finding...
The laureates. No, the laureates themselves as personalities.
Not really. I've listened to talks to them, but I don't know them personally.
Yes, we heard Professor Zeilinger talk, and he was really surprised and happy, of course. So, finally, if you could tell me in 30 seconds why you specifically are so excited by this prize, what would you say?
Well, quantum mechanics is an old love of mine. I wanted to become a mathematician. When I took a course in quantum mechanics, I decided to become a physicist. So quantum mechanics is the thing that made me study physics, and I think I'm not the only physicist to have that experience.
And the quantum world itself?
That is something that you never get finished with. You always ponder, what is it? How do you understand it? And you try to go deeper and deeper into it.
Thank you very much, Professor Tor Hans Hansson, member of the Nobel Committee. Thank you.
Okej, fick du vad du...
Det var suverän. Bra gjort där.
Ведьмак.